Good evening, all of you. So, in day 24, we are going to discuss about a double linked list. So, in day 24, we are going to discuss about double linked list. So, I will just review what you have discussed in the day 24. So, after that, we will go and discuss about a circular linked list. So, what is a double linked list? So, what is the difference between a single linked list and double linked list? So in a single linked list, it contains only two fields, that is the data field and the address of the next node. So whereas in a double linked list, it contains the node contains three fields. So that is the address of the previous node and data field and address of the next node. So address of the previous node and the data field and address of the next node. So that is the difference between single linked list and a double linked list. So and also in a single linked list, you can travel from only one direction. So that is from starting node to end of the node, and it is not possible to travel from last node to starting node. So whereas in a double linked list, you can travel from first node to last node and as well as the last node to first nodes. So that can be possible with the help of a double linked list. And what are the operations can be performed on a double linked list? So that is creating a double linked list and insertion and deletion and travel and searching. You can search a particular element in a linked list and count the number of nodes in a linked list. So and again the insertion can be performed at three places, that is inserting at first position, or inserting at last position, or inserting at a middle position, and similarly deleting at the first position or deleting at last position and deleting at a intermediate position, that is between the elements you can delete the elements. So that type of operations can be performed on a double linked list. So same operations will be also performed on the single linked list. So the difference is that in a single linked list we will going to travel from first node to last node, but it is not possible to travel from last node to first node. So whereas in double linked list, it is possible you can travel from first node to last node as well as last node to first node. And one more difference is that in single linked list, the node contain only two fields, that is the data field and address of the next node. So whereas in double linked list, the node contain three fields, that is address of the previous node and data field and address of the next node. So that is the difference between single linked list and double linked list. And in day 24, I explained how we'll go to perform it, how we'll go to create a node, and after that how we'll go to insert the nodes in a at beginning of the position or last, or you can place the node in at last position of the linked list, or you can inserting at between the nodes, and similarly deleting. So you can delete a first node, or deleting last node, or deleting intermediate node, yeah, and followed by travel. You can travel from first node to last node and the last node to first node. And after that, you can also perform searching how many elements are there, or if you want searching a particular element in a linked list, then it is also possible in a linked list. And a counter, you can count the number of nodes in a linked list. So that's what we are going to discuss in day 24. So now it is at day 25. So in this class we are going to discuss about circular single linked list. So circular single linked list. So actually the circular linked list can be classified into two types. So that is a circular single linked list and circular double linked list. So if it is a circular single linked list, so the node contain only two fields, and if it is a circular double linked list, the node contain three fields. So that is the only difference here. And one more difference between when compared to the single linked list or double linked list, the difference is that, so in a circular linked list, so the last node, the address of the last node, which can be stored into the first node, and similarly the address of the first node can be stored into the last node. So that is only the difference between other linked list and the circular linked list. So here I mentioned some of the uh, statement here, that is the basic operations that can be performed on circular linked list are similar to the linked list only. So what are the operations can be done on a single linked list or double linked list? So same operations will be also done on a single circular single linked list or circular double linked list also. So the difference is that the last node address is going to store into the first node address. So that means the last node at the address of the last node, which will going to store into the first node. So that is only the difference when compared to other linked list. And the same operations will be also done on a circular linked list, that is creating a list and inserting, deleting, and travels or count the number of nodes in a linked list, and also can perform searching operation also. So creating an creation of a list. So the creation of a list, it will involve three process. So creating a node. So with help of a temp node or a node or whatever name you have to provide to the node. So with help of that node and by using a malloc function, you are going to create the nodes. So after that, we can read the data into the data field, and after that we will go and connect the newly created node to the linked list. So that is about creation. And coming to insertion of nodes in a circular linked list, so that will be also performed on inserting at first position or inserting at last position or inserting at intermediate position in the linked list. So this is a circular linked list. So I said that the address of the last node. So the address. So what is the address of the last node? So that is a FEE7. So this node, which will go to store into the first node. So in this example, I have only two nodes, that is a node 75. So the data is 75, and for node 2 it contains 530. So now 530 is the last node in my linked list. So that's why the address of the second node or last node, which will go and store into the first node. So that is only the difference here. I hope you'll be understanding what I am saying. So whereas in single linked list and double linked list, we are not going to store the last node address into the first node. Clear what I am saying? I hope you will be understanding what I am saying. So the last node contain address of the first node. So that is only the difference here. And same operations will be also done on like as a single linked list and a double linked list. So this is about inserting node in the last position. So you are going to insert the nodes in at a last position. So that means whatever the node you are going to create it, so that address can be stored into the first node. And intermediate also, it is possible you can insert the newly created nodes into the circular linked list. So if we know all these insertion operations thoroughly, so then it is very easy to understand the programming language. How we will going to implement insertion operation, or inserting at the beginning, or inserting at last, or inserting at middle position, and similarly deleting. So deleting at first position, or deleting at last position, and deleting at intermediate. So that will be very easy if once we'll be know how we'll going to perform insertion and deletion operation. um, then it will be very easy to write the program in C programming. So this is inserting at first position. So I'm going to insert the first node. and the last node is FE7. So this node address will be stored into the newly created address, and address of this node will be pointing to the next node. So that is deleting first node and deleting last node and deleting a intermediate node in the linked list. So once we will be thorough, how we will going to perform all these operations. So then it is very easy to write your own code or your own algorithm for insertion, deletion, and travel or searching and so on. Now let us see how we will going to execute this circular linked list, single linked list in C programming. So for that, what you have to do? So you have to open the Turbo C++. So I want to open the Turbo C++. So now I'm going for open. So I already saved my program in my computer. So that is a program on circular single linked list. Now you can compile the program. So by pressing Alt F9. So there is an error in my code, and now for execution of your program you can press Ctrl F9. So this is a menu. So in this menu it contains number of options like inserting in beginning, inserting at last, deleting from beginning, deleting from last, and search for an element, and show. Show is nothing but display, and the last one is exit. Now let us see first one. So I'm going to select option 1, and the data is 1. So now that the node will be inserted successfully into the linked list. Now I'm going to choose choice 1 and node 2. So now the node 2 is inserted. So that message will be displayed in the monitor. So next one, choice 1 and data will be 3. So now the 3 node is inserted successfully. Now you can display. So for displaying you have to use option 6. Now you can see here. So it will be contain first node will be 3 and second node will be 2 and the last node will be 1. Okay, clear what I am saying? So I inserted uh, 3 1 2 3 or 3 2 1. So now I'm going to insert next node. So now I'm going to choose a second option. So inserting at last position. So now I'm going to take fourth. So now the fourth node is inserted at last position. Now let us display. Now see here. So the insertion value that is a 4. The 4 will be inserted after 1. So why? Because the 3 is a first node and 2 is a second node and 1 is a third node, and if you want to insert any other node, that will be inserted after 1. For example, if you want to insert at beginning, that is a 3, before 3 you want to insert, for that you can go for choice 1 and data will be 5 and display. Now see here, now the list content 5 3 2 1 4. So that is about inserting at a beginning or inserting at a last position. So next one, now I'm going to choose option 3. So that is delete from beginning. So what is the beginning element in my linked list? So that will be 5. So 5 is the beginning of the element. Now I'm going to delete that element from the linked list. Now the choice is 3. Now press enter. So now it will showing node deleted. Now can display once again. Now see here. So previously it contained 5. So the uh, first element will be 5. So now the 5 will be deleted. Now the remaining elements in the linked list will be 3 to 1 4. So on the next one, similarly, deleting from last node. So what is the last node in 3 2 1 4? So 4 is the last node. Now I'm going to choose option 3. So I will select the option 3. So then it will go and again deleted the beginning of the node. Now what are the elements are there in the remaining? So 2 1 4. Now I want to delete 4. So that is deleting from last. So the option is 4. Now press enter. Now display again. Now the 4 will be deleted and the remaining nodes in the linked list will be 2 and 1. So 2 is a beginning of the node and 1 is the end of the node. So now I want searching. So for searching the option is 5. So now I will be look at for example I will be give 7 whether I want check seventh element is there in my linked list or not. So the seventh item not found. So why? Because we have only 1 and 2 only. So that's why it will showing the 7th item is not found. And finally we can exit by choosing a option 7. We'll go and exit the program. So now we'll be come back to your program. So these are the operations can be done on a circular linked list. I hope you'll be understanding what I am saying. And if you have any doubts, you can please post your queries in the chat box, and I will try to answer your query. So that's all about circular linked list. And now coming to difference. So what is the difference between single linked list and double linked list? So I said that. So I said that the difference between a single linked list and a double linked list and double linked list and a circular linked list. So in a single linked list, the node contain only two fields. In single linked list, the node contain only two fields, that is a data field and address of the next node. So whereas in a double linked list, the node contain three fields. The node contain three fields, that is a address of the previous node. So the address of the previous node, and second one is a data field, and third one is address of the next node. So these are the fields that double linked list contain. So next one, in a single linked list, you can travel only in one direction. In single linked list, you can travel from first node to last node, that is only one direction. But it is not possible you can travel from last node to first node. So that's why, so in single linked list it permits travel only in one way or only one direction. So whereas in double linked list, so it permits two ways. So that means we will travel from first node to last node, and as well as the last node to first node. And next one is a single linked list consume less memory space. So why? Because it contains only two fields, that is a data field and address of the next node. So whereas in double linked list it consumes more memory space. So because of the node contain three fields like address of the previous node, data field, and address of the next node. So that is the difference between single linked list and a double linked list. And one more difference is that in a single linked list, the insertion operation and the deletion operation can be going to take big of n times. So the single linked list, in a single linked list, the insertion operation and the deletion operation is going to take big of n times. So whereas in a double linked list, the insertion and the deletion is going to take big of one time. So that means that while performing insertion operation, we will go to traveling from first node to second node to third node, and so on. And similarly, if you want to delete a last node in the single linked list, then you will be travel again from first node to second node to third node, before but one node. After that, you can perform deletion operation. So that means it will go and compare n number of elements. So that's why the insertion operation, the deletion operation is going to take a big of n times. Whereas in a double linked list, so the insertion operation and the deletion operation can be done very fastly. So that's why it will go and take only big of one time. So these are the difference between a single linked list and a double linked list. Now, what is the difference between a single linked list and circular linked list? So the difference is that I said that if it is a circular, if it is a single linked list, or if it is a double linked list, so the node contain two fields, or the node contain three fields. So whereas in and similarly in the single linked list or double linked list, the last node contain null address. The last node contain null address. So whereas in the circular linked list, the last node contain the address of the last node, which will go to store into the address of the first node. So the last node address can be stored into the address of the first node. So that is the difference between uh, linked list and followed by circular linked list. So these are the difference between linked list and a double linked list. Now coming to applications. So what are the applications can be performed on a linked list? So that will be dynamic memory allocation. So the linked list will be comes under dynamic memory allocation. Like a pointer will be comes under dynamic memory allocation, and array and structures will be comes under static memory allocation. So next one, with help of this linked list, it will be implement the symbol tables in a compiler conversion. So in compiler conversion, we will going to construct implement the symbol table. And next one is with help of this linked list, we will going to implement the stacks and queues also. Like stacks can be implemented with help of a linked list, and queues can be implemented with help of a linked list. So that is about a circular linked list. So if you have any doubts, you can please post your query in the chat box. So any doubts, please post your query in the chat box. And the next one is stacks. So what is a stack? So it is an order collection of elements. So stack is a order collection of elements. So in which the insertion and the deletions can be take place only one end. So that end is called as a top of the stack. So that means only top of the end will go to perform insertion operation and deletion operations. So that means the stack will be looking like this. So from this stack, we will going to insert the elements into the stack, or we are going to delete the elements from the stack. So that means the insertion operation as well as the deletion operation can be performed only through the top of the stack only. So why? Because the insertion and the deletion can be carried out only through the top of the stack only. So next one, the stacks are also known as piles, or it will be also known as a push down list. So the stack can be also referred to as push down list. So why? Because we are going to push the elements into the stack, and we are going to uh, delete it. So we are going to pop the elements from the stacks. So that's why the stacks are also known as piles and push down list. And similarly, for example, so what is the element? So what is the element you are going to place into this stack? So that element can be stored into the bottom of the stack. For example, this is a stack, it contain only one end, that is the top of the stack. So this is a stack. So now if you want to insert a first element into this stack, so that element can be goes through the top of the stack. For example, I inserted one. So then the element can be inserted through top, and then the item will be going to store into the bottom of the stack. And similarly, if I inserted second element, so then it will be inserted after the one. So uh, that means after inserting of a first node, then the second node can be stored top of the one. And similarly, if you want to insert a third node, so that will be there in the top of the second. And if you want to insert fourth, that will be there in the top of the third node. So like that, we will go to perform the insertion operation, as well as we'll go to delete the elements from the stack. So in this example, the first element can be placed into the bottom of the stack, and the last element can be placed at the top of the stacks. So that's why the stacks can be referred to as a last in first out. So that means that, so what is the element you are going to place? What is the element you are going to place as a first? So that will be stored into the bottom of the stack. So that means that, so this first element can be removed. So can be removed only in last. I hope you'll be understanding what I am saying. So the stacks, the first element can be stored into the bottom of the stack, and the last element can be stored into the top of the stack. So that's why the last element can be deleted. Uh, sorry, last element. What is the last element in this example? That is a 4. Okay, so when will be delete the first element? So after deletion of a fourth node and third node and second node, so then only it will be possible to delete the first node. So otherwise, it is not possible without deleting a fourth node, third node, second node. It is not possible to delete the first node into the stacks. So that's why, what is the element you are going to place into the last, that will be going to delete it as a first. That's why the stack can be referred to as a last in first out. So what is the element you are going to place as a last, that element can be deleted as a first. So for example, so I'm given here some disk here. For example, if you want to buy a CD, so then you have to go to the shop. So on that shop, all CDs will be placed like this. So there is a shop, there is a shaft will be there. So on that shop, we are going to insert the all the disk into the this for this shaft. For example, the box, the CD box, it contain 5 CDs. So in this 5 CDs, for example, if you want to remove bottom of the CD, if you want to remove bottom of this CD, then it will be possible. You have to remove fifth disc, fourth disc, third disc, and the second disc. Then only you can remove the first disc. Otherwise, it is not possible to remove the first disc from the CD box. I hope you will be understanding what I am saying. So what is the element you are going to insert it as a last? So that element can be going to deleted as a first. So that is the principle the stack is going to work. And similarly, so now uh, I will take one more stack here. So now I'm going to insert the elements into this stack. So before performing an insertion operation or pop operation or push operation, you need to check whether this stack is empty, or you need to check whether this stack is full or not. For example, if the stack is full, then we are not going to perform insertion operation. Clear what I am saying? If the stack is full, then you are not going to insert any more elements into the stack. And similarly, if the stack is empty, so if the stack is empty, then it is not possible to delete any elements from the stack. So these are the two conditions you have to verify at the time of you have to verify at the time of pop, and at the time of push operations can be done on the stacks. And similarly, while performing insertion operation, so the top value initially pointing to -1. So the whenever the stack is empty, then the top pointer which will go to pointing to -1. So whenever you are going to insert a first element into the stack, so then the top value is going to incremented by 1, and it will go pointing to the top 0. So why? Because it is a index number 0. I hope you'll be understanding what I am saying. So whenever you can perform a insertion operation, so then the top value is going to incremented by 1, and it will go pointing to the first element in the stack. And similarly, I inserted a second node, then the top value is going to incremented by 1. Let us take this is 1, and the top value is going to incremented by 1, then the top value will be placed at second element. And similarly, whenever you are going to insert a third node, so then the top value is going to incremented by 1, so then the top value is going to pointing to the newly inserted node, that is a 3. So like this the top value is going to incremented by 1. So whenever you can perform a insertion operation or push operation. And similarly, whenever you are going to delete a last element into this stack, so then the top value is going to decremented by 1. So whenever we are going to remove the elements from the stack, so then the top value is going to decremented by 1. So then it will go reach to the top is equal to -1. So when it will be reached to the -1, we are going to delete all the elements from this stack. So if you are going to delete all elements from this stack, so then the top pointer will be reached to the -1. So whenever the top pointer will reach to the -1, then you can say that the stack is empty. I hope you will be understanding what I am saying. So whenever the top value will be reached to the -1 while performing a deletion operation or a pop operation, so then you can say that the stack is empty. So that is about stacks. So for complete details, we'll go and discuss in the next class. And that's all about today class about circular linked list, and followed by execution of the circular linked list program, and about stacks. So if you have any doubts regarding circular linked list and regarding the stacks, so I will explain the different types of operations can be done on stacks in the next class. And I will explain the stacks can be implemented with help of a linked list and with help of a array in the next class. So up to now, if you have any doubts, you can ask me. I will try to answer your queries. So that's all about today class. So if you have any query, you can post in the chat box. So otherwise, if you don't have any query, so that's all about today class, and we will go and meet in the day 26. So thank you. So thank you for attending the session.